Here's the Earth, and we're out in the middle of outer space. We're looking at the Earth from above, although is there an up and down when you're in outer space? Well, we'll leave that for another time. And let's pretend for a second that there is no sun. That would be bad because we would not exist, the whole planet would be frozen, but just imagine for a second there is no sun. The Earth is moving, maybe, let's say it's moving this way. I'm just making this up. If there were no sun, then there's nothing pulling on us. The Earth would just move in a straight line according to Newton's first law. And it would keep moving in a straight line until something exerted a force on it. Fortunately, that's not the case. Fortunately, the sun is here. And as a result, the sun pulls on us. The sun exerts this gravity force. It's attraction, so the sun is pulling us in toward the sun. This is a weird idea. Newton said that the gravity equation applies to every two masses that you pick. So look around the room. Pick any two objects. Maybe it's the flag. Maybe it's the water bottle on your neighbor's desk. Those things are pulling on each other. They exert a gravity force on each other. They attract. Pick two other objects. Maybe it's, your shoe. Maybe you're wearing moon boots. I don't know. And the other object is perhaps, the tiny little thumbtack in the bulletin board. Those two objects pull on each other. Why? Because they have mass, so they're attracted by gravity. Every two objects that you pick, no matter how far they're separated, feel a gravity force. This is such a strange idea. And it applies to planets. Every two objects, like the Earth and the Moon, we'll call this M1, we'll call that M2, they are attracted to each other by a gravity force. Wait, did I call this the Moon? That's the Sun. So because of this force, we don't go in a straight line. We're getting acted on by an external force. So the velocity kind of swings over, and as a result, we move in this circle. We call it orbit. But this is weird. I gotta be honest. Okay. I teach physics. I already know what gravity is. Here I am with my coffee, although I need more, because I keep calling the sun the moon. I already know what gravity is. Gravity is the force that pulls me down to the Earth. Gravity is the force that keeps me from floating off into outer space, right? Well, apparently, gravity does something else. If we look back to the equation, it is truly incredible. You can pick any two objects you want. Make the first object, M1, the Earth. Make the second object, M2, the Sun. They pull on each other with a gravity force, according to the equation. But, maybe the first object is me, the teacher. And the second object is the Earth. They pull on each other with this gravity force, which is why I don't go floating off into outer space. Now, for me personally, that's pretty mind-blowing. Gravity is it's like magnets. Any object that has mass is like a magnet. Now, your shoe, your moon boot, and the water bottle, they don't have enough mass to actually feel the force. The force they feel, the attraction, is really, really weak. Maybe it's like, that many newtons. It's a really small force. You can't feel it. To feel the force, you need a huge object, like the Earth or the Sun. And if that wasn't mind-blowing enough, let me ask you this question. Is the Earth falling? Why would I ask? This feels like a weird question. It's kind of out of left field, right? Out of nowhere. Here's why I ask the question. We have this fancy term that we use at parties to make ourselves sound smart. It's called free fall. And what's the definition of free fall? Oh yeah, free fall is when an object only feels the force of gravity. Okay, like for example, if you're standing on the grass, here you are, and you throw the ball as hard as you can. Well, maybe, okay, that's not very far. You throw the ball as hard as you can. While the ball is here, it's getting pulled just by gravity. While the ball is here, it's getting pulled down just by gravity. So it's in free fall. That's free fall because all it feels is gravity. But wait a second. Look back at the planet. Look back at the Earth. All it feels is gravity. So is it in free fall? To answer that question, here you are. Okay, here's the Earth. This is my favorite. I love this. Okay, here's the Earth. I don't love drawing the Earth because I'm really bad at that. Maybe here's South America. Oh, is that Texas? And here's the tallest mountain in the world. Apparently it's on the North Pole. Okay, ignore that. But you climb up to this really tall mountain, and like, hang on, here's Europe, maybe that's like, is that France? And you climb up to this really tall mountain, and you do what you just did before. You throw the ball. And you are strong. It goes all the way into the ocean. That's pretty impressive. But you can do better. You climb down, you work out, you go back up, and you throw it again, and you make it all the way to Europe. So you climb down, you get a personal trainer, you work out some more, you climb back up, and the next time you throw the ball, it goes all the way over to there. And then you go into a dark place. You know, you separate from your friends and family. Maybe you use steroids. All you ever focus on is working out. But you get so strong that you can throw the thing clear into outer space. And, finally you realize you need to turn your life around. You turn to physics. Physics brings you back to the bright place. And you say, maybe I can turn this into an experiment. You climb back up. You stand there at the top of the mountain looking around, and you say, well, wait a second. What if I throw the ball a little harder, and it goes down to South America? And then you say, what if I throw the ball just a little harder, and it goes all the way over to there? Don't ask me what that is. And you realize, maybe there's this sweet spot where I throw the ball, and it just keeps going. It never lands. Let me try that again. You throw the ball at this sweet spot, and it just keeps on falling. When the ball is here, it's getting pulled toward the ground by gravity. When the ball is here, it's getting pulled toward the ground by gravity. When the ball is here, it gets pulled in toward the ground by gravity. And likewise at every point. It's in free fall, right? Because it's falling, but it's also in orbit. Free fall and orbit are the same thing. It's just that in orbit, the object never lands. The moon is going around the Earth. It is falling toward the surface of the Earth, but it just never lands. The Earth is going around the sun. Here it is. When the Earth is here, it's falling. When the Earth is here, it's falling toward the sun. We just never land. Is the Earth falling? Yes. It is in free fall.